Welcome to 3-week workshop on programming in C++. In this video, I am going to explain the concept of templates in C++. So normally the template is the important features of a C++ programming language which supports the concept of generic data types. So normally this template will act as a placeholder for the compiler so that during the compilation the concept of the templates will be replaced by the corresponding data type. So that it is normally this template will support for all the basic data types. Normally it will be suitable for code reusability purpose. But let us take simple example. If I'm going to perform an addition operation on different data type, for example, for different numbers, different category of a number. For example, if I want to write the addition of two number, it maybe belongs to both our integer data type, or maybe on integer or float data type, or maybe it is on float and double data type, or maybe double data types, or maybe a float data type. So for this, we need a different number of combinations we need to write for execution, for adding a two number logic. For example, before going to discuss about a considered template, so first of all, I'm going to write a code without the help of any template concepts. Assume that I'm going to provide I'm going to write a code for addition of two numbers. The first one for integer category. So it's out of answer equal to, I'm going to just adding these two values. So this is for integer category. So we know that there are different possibilities we can able to write for the same one because of this different data type. Here I'm going to write, I'm writing the concept of specific. For example, one category is an integer, another category as a float. And the next thing is, I'm going to write another one more thing, just another, this is float. And I'm taking the first one concept is a float. And second one is as usual integer. And the next categories I will go with the float. Both are in float category. And next thing is I will go with the integer double combinations now. Int and double. So then the next thing is I will go with into double, then so here integer, so here I will go with the double. Maybe we can do it for a float. So that's on our choices only, then we can make it as all are double. So then we can try for the same thing. Edit the paste. For float and double combination. So here it is a float and here it is double. And I'm going to write the same code for double float. So for implementation of the same concept, we are varying with a different data type of the arguments. We have different number of combinations. One is for integer category. Second one is for int float, float int, and float float. Say if you are mingled with the double and integer, same way for float and double. So these are the different number of possible combinations we are able to implement for a simple same concept. See that these are the different number of functions we are writing. So that here the logic, everything is same, only the differentiated on the parameters. So if I'm going to call the function, for example, add 3, 4, here 3 and 4 as integer, so that it makes a function called as integer, integer. So next I'm going to write another one more, that is called 3.4f, 6.7. So one is this is called float and double. Now you have to compile and check for even we can face the problem of ambiguity issues also if you're not having a proper data type, so that it goes to proper data type conversion. So that means the proper data type means if you're not specifying the data type of argument is properly, so that it will go with assumption, so that there is a possibility of ambiguity issues. But here we have an explicit data type conversion, so that there is no ambiguity issues will be created. Okay, so now, so we know that this is for integer, and this is one for float, and second one is then not the return anything is not written for a fractional number, so that it invoke for it will assume for a double, so that it invoke for a double data type. So just I'm going to make a call. So by just I'm going to run it first, then I can show by the help of f7. So now I am going to trace the program execution. Now we know that this is the function execution will be predicted at the time of compilation itself. So that automatically will call integer concepts. Integer function means that both the data type of integer. The next one is match with the float and double. So now it match with the float and double and it executes. In case if I'm going to represent say f here, so that automatically go for float. So according to the data type, the functions means that the compiler can predict the corresponding execution of the function, so that automatically we can get which is the function or means that the compiler can predict it. So see that for the same logic, the length of the code will be increased, so that it that means that we feel it is a very difficult to understand, which means maybe we can miss any one of the data type, then automatically there is a problem of ambiguity will be created. So that means this is the general way of expressing the concept of programming. Means general special way of handling the data type for all same concept. So that is in order to avoid these confusions, the compiler supports the concept of a template concept, so that the template will be act as a placeholder for all data types, so that the template is also called as a generic programming. So in this case, just simply we are going to implement the concept of means we are going to define the generic data type, so that we are not going to define any specific data type. So just we are going to define only the generic data type. So based on the data type, the compiler predict which is the function going to replace. So it is a placeholder only at the time of compilation itself. It will be created, so that during the compilation, the based on the data type of the argument, that means the data type of the data type for matching with the template, the separate definitions will be created, so that the template will be act as a blueprint or formula for creating a generic class or function. So there are two keywords normally we need to know about for implementation of the template. One is a template. Template is a keyword for implementation, for indication. The next one is class or type. Actually, the type name is not suitable. It's a for class. So these are the two concepts, the two keywords we must be familiar with to work on template. So generally, there are two possible ways the template can be implemented, either maybe in the concept of function or maybe in the function or concept of class template. Okay, so if you want to implement the template, first of all, we need to define what are the template classes we are going to define. We have to define n number of template classes according to our convenience. And second one, we have to use the template classes according to that requirement. So for example, if I'm going to implement in the function template, so that we have to define the name of the class template in a function name. Same if you are going to use a class template, we can use it in class name inside of the class definition. Okay. So let us to take a simple example. I'm going to map the same thing. So first of all, I'm going to define the template first, so that you can use the keyword as a template. So template is the keyword. Within angle bracket, we have to define n number of classes for the template. For example, as you see here, I'm going to use only one template class. So that class is a keyword. Or then we have to define what is the class you are going to define. So this is the name is given by the user defined thing, so that you can give any name for this user defined name. So instead of this explicit data type, we have to define what is the template what is the template concept you want to use. So in this case, so that add is a function, so that t means that t is a template class, so that at the time of compilation, according to the function call, the compiler version will be created according to the function call. So here we are representing add 3, 4. So this is integer. So automatically after the compilation, the compiler create a specific version that void add int a comma int b. The logic is as usual thing. It will be created. And for the next function call, it is a float category. So that it will be created as there are two functions will be created, that is called compiled version after compilation. So this is the actual content of the program. So float a comma float is just that means that the P, that is called the placeholders, will be replaced by the corresponding data type. So that we call as generic data type. So now we have to compile. So this is the compiled version. So the compiler only can generate. Means that this is for understanding only, just I'm specifically written here. So you have to define, means the compiler can replace this a placeholder. Placeholder means, so this is the name of the placeholder. So wherever we have this placeholder P, it will be replaced by the corresponding data type by the compiler according to the requirement. So now there is no error. So this is the first step. We are going to define the template list of template classes. Here I'm going to define only one template class I'm going to follow. And next thing is I'm going to use this template classes wherever we require. So here I applied the concept of the template only in a function, so that this is called function template. So here I'm using the concept of generics in a function, so that it is called as function template. Now I'm going to compile. So no error, just I'm going to run it. So it will be displayed, it will generate. Now I'm going to trace the function execution as usual. We know that it will be executed as usual thing. So automatically it go and execute it. So it go for the function body. Just let us take the concept like this. Here you are not following the template concept. So if you have the definition like this, so assume you have a definition like this, and so I'm going to implement logic inside of it. This is not a generic programming. So here I'm using specialized way. We have written the code for all the basic data types. So I'm going to just simply adding the value of A and B. Here also same thing. So the same code, the same logic just replace. So now if I'm going to press F7, so 3,4, see the differences. If you are using a template, only the body of the function will be used. But if you are using not generic concept, so that it execute from the function definition. That means a match with the data type and work. So that it will work as usual thing. I'm going to run it once again. A plus B. Okay, so just to see that, now we have to see the difference. So with the help of the template concepts, now I'm going to compile. So no error, just I'm going to trace the execution. So see that the function, that means that the body of the functions only will execute, so the compiler can replace with that. So here I use the concept of template. Here I use the concept of templates in now in function, so that it is called as a function template. So let's see that. So that totally I nearly written 10 possible cases for the same thing. Even if you want, you can multiple classes also. The class T2. You can compile. Sorry, I did a mistake. Just you can replace it with a name. So T2 is not an argument. Type argument. So sorry. So I'm going to use class T2. Yeah, so function T2 is not used in any arguments type. So that, for example, if I'm going to represent like this, then automatically the T1 and the T2, based on the data type, it can be assumed. For example, so for this case, if you are going with the multiple template concepts, here 3 will be an integer and 4 will be an integer. So that in this case, the data type of T is an integer. So here T is a placeholder, T1 and T and T2 as a placeholder, and it will be replaced by the integer for the first function call. It's the same way for the second one. So 3.4f, it will be assumed as a float, so that the t will be assumed as a float. And same way, 6.7, we know that it is a double because the default data type is a double. So that it will be assumed, T2 will be assumed as a double. So that according to the convenient, whatever we have, it will be replaced. So that only we call as a placeholder. So here we are using a multiple template classes for a function template. So that is all our convenient. It is not necessary to restrict for only one data type. We can use it for any number of template classes for our convenient. Now we have to check the output. It will have a same answer. Now you have to show how the function executed by tracing on it. So it will be matched like this. So it will work as usual thing. Okay. For example, if I'm going to use the same concept for the class definition, for example, class, I'm going to create as arithmetic. So in this case, so here I'm going to use bubbling because we are going to access this method. Here I didn't create any function, but actually I'm using inside of the class. And so that here I'm using a class template so that we know that these are the method will be accessed by using by using object. So that my function name is arithmetic. So here before creating object, we need to define what is the data type will be suitable. For example, I am going to say int comma int. So because there are two template classes I have, so that I need to define what is the two template classes int comma int. So if I'm going to call this a method f.add, for example, just I'm going to only one thing. So now I'm going to compile, no error, then I'm going to run it. So I'm going to trace, before I see the output as 7, now I'm going to trace in. So automatically the T1 will be assumed as integer and T2 also will be assigned as integer by using a placeholder concept. So then it will be replaced. So for every data type, it will be created. I mean, so for every class, different data type, the separate classes will be generated. Clear? For example, if I'm going to say that f.add, just you can see that what is the output, then we will discuss about that. So then only we can have a clear idea about it. Sorry, I'm going to run it. It will show only 9 because here while creating an object you are saying that the template is suitable for integer and integer. So that if you are passing any other data type, so that it will be converted to the integer and the work means that the execution will take place. So that the 3.4f will be converted as integer, so that we know that if you are converting fractional into the integer, only it takes only the whole part. So that it takes a 3 for the first argument and second argument 6, so that it returns 9. So now you have to trace how it will execute. So that only we are saying that if you are with multiple data type, then we can work with, we can create some other object also. For example, so arithmetic, so arithmetic, you are going to define that int comma float. So I'm going to create another one more object as f1. If I'm going to say f1, so the answer is 3 plus 6.f. You can check it, 9.7. The first one is integer, so that for f1 class, the t will be assumed as an integer, and this 6.7 will be assigned as a float. Sorry, it is a float. Then it will work. So that only the difference between your class template and the function template is normally we can use the template only on the function. So that it will work only that while making a function call, it can pick it. If you are using the constant template inside of the class, we need to define what is the type of the template we are going to use it for those template classes. So the number of data type depends on the number of arguments we have. So that during the template assignment, I am defining two templates, so that I need to define two template, two data type here. If I'm going to define only one data type, and we can check it, what will happen. So there is an error. Too few arguments in template class name. So that is the error will be created. So that now we need to define the number of matches will take place. So here there are two template classes we have, so that we need to define two template data type, two specific data type for matching. So that only we are saying that. So that only we are saying that the template will be act as a placeholder, so that the compiler replace the placeholders by actual data type. So after compilation, for example, for the first one we are taken as an integer comma integer, so that there is a separate class will be created for integer and integer, and there is another one more class will be created for same arithmetic with a different data type. So so that it will be act as a blueprint. It is a common format. And so because of this template, there are two possible advantages we'll gain. There are major advantages we got. One is a code reusability, and also it is a flexibility to work on it. So that it is a powerful tool for implementation, so that the length of the code automatically will be reduced and it can be reused. So that only the template, the advantage of template is called code reusability. So normally this template concepts will be also called as generics in Java, and as well as in C# also. And so normally we prefer this generic data, these kind of languages, but only the way of implementation may change, but the remaining things are as usual. So so that if you think that if you want to create a one function, whenever you are going to create any function to suitable for any data type, we can go with a generic data type, so that it will reduces the length of the code. So it will be support for a generic programming. So compiler will act as a placeholder, so that by using the placeholders, automatically it replaces, so that after the compilation it will generate the specific data type. So this is the way we are implementing the concept of templates in C++. Thank you.